All right, we need to go over 5C1 and 5C2, the pressure conversions, and the first sheet on station models. That's the goal here. So you have the sheets from the classroom yesterday. So the first one, we had to convert 2 millibars from the station model code. Second one, we had to put into the code from millibars. And the third one, which is certainly the most challenging here, you convert it and then you figure out what the pressure was 3 hours ago based on the barometric trend. I have it all set up over here, so I think we'll do it as PowerPoint instead. All right, so 5C1. So if it's less than 500, you put a 10 in front. If it's more than 500, you put a 9 in front. So the first one, we put the 10 in front, decimal between the last two digits. So 135 turns into 1013.5. 852, being more than 500, gets the 9 on the front, decimal point between the last two digits. That always happens. So 985.2. If you do these correctly, they should end up between 940 and 1040 in reality. Those are realistic pressures on the planet. Not to say it always has to be in there, but anything we do is going to end up in that range. So if you get values like 910, you probably did it wrong. So that's the way you can check yourself, is go between the two numbers. All right, so we'll just kind of quickly go through here. I'll explain a few more, but then we'll just rip them off, because once you get them, they are super duper easy. All right, so 268 is less than 500, so it's going to get a 10 on the front and a decimal between the last two. So when we do that, we get 1026.8. D804 is more than 500, so it gets a 9 on the front, decimal point between the last two, 980.4. 985, definitely more than 500, so we put a 9 on the front, decimal point between them, 998.5. All right, so I think we're getting it. Next one's more than 500 as well, so 977.0. G is less than 500, way less than 500, 057. So it's going to get the 10 on the front, decimal point between the last two. So 1005.7. All right, so hopefully you get that. Check yourself before you wreck yourself. There you go. So those are the conversions. Now, sometimes you have the station model and you want to convert it back into regular format like we just did. Other times, I'm going to ask you to put it on a station model, so you need to be able to put it in the 3-digit format. Now, in order to do that, we just work it in reverse. If we have a 10 on the front, we're going to take it off. If we have a 9 on the front, we're going to take it off. We get rid of the decimal point between the last two digits. So it's the complete opposite of what we just did. So 1023.6 turns into 236. 994.2, we ditch the 9 off the front, the first 9. We keep the 942, we get rid of the decimal, 942. 980, going to ditch the leading 9, get rid of the decimal point. So on a station model, we just write 800. Next one, same deal. Ditch the leading 9, keep the 6, keep the 8, keep the 4. No decimal point on the station model, so 684. Next one, this has the 10 on the front, so we're going to get rid of the 10, keep the 349, no decimal point, 349. Pretty straightforward, I think, right? Right? Say yes, even though you're talking to an inanimate screen and I'm not really there, just pretend. All right, so here we go. I will give you the rest of these. We lose the 9, 777. We lose the 10, 075. We lose the 10 again, 211, 101. There we go. Now the last one, it shouldn't confuse you, but it might. You're going to get rid of the 10. You keep zeros. Zeros matter. So 001 is what you're going to have there. So there is how we convert it back into station model format. And question 3 here. So we have the station model format, the 3 digits with the 893. We have the pressure trend, minus 13, which if you watched yesterday's video and use your reference tables, you know means the pressure has gone down in the last 3 hours. not 13 millibars, but 1.3 millibars. If you want to know what the pressure was 3 hours ago, you're going to have to put it back on and add it to the current pressure. So we'd have 889.3 when we convert this. We put the 9 on the front and the decimal point in. It's gone down 1.3 millibars, so we're going to add 1.3 back onto it. And I'd use your calculator, probably. You get 990.6 millibars. They work the same way. All right, this one, less than 500, so you're going to put a 10 on the front, a decimal point in between, so it turns into 1,013.7. The pressure trend is plus 11, which means in the last 3 hours it's gone up 1.1 millibars. There's always a decimal between the two digits in this particular spot on the station model. So 1,013.7, we want to know what the pressure was 3 hours ago. We're going to have to do the opposite of this. So we're going to subtract 1.1, get 1,012.6. Next one, okay, less than 500. It's going to get the 10 on the front treatment, decimal point. So you're going to have 1,001.2. In the last 3 hours, the pressure's gone up 2.3 millibars. So 1,001.2. If we want to know what the pressure was 3 hours ago, we're going to subtract those 2.3 back off the current pressure. So 3 hours ago, the pressure was 998.9. I mean, it's not super easy, but it's not super hard either, right? I mean, it's doable. First you convert it, then remember to do the opposite sign, and you'll be fine. So this is 996.5. We're going to add 1.8 millibars back onto it in order to find the pressure 3 hours ago, 998.3. Now, this section has us working through like we always have to know what the pressure was 3 hours ago. Honestly, I'm not going to ask you that every time. Just making sure you understand how this works. So the pressure trend's important because if the pressure is rising, that usually indicates cooler, drier air moving in and nicer weather. High pressure is typically nice weather. And if the pressure is dropping really fast, that's a sign that a storm is coming 9 out of 10 times. Also, you're going to have windy conditions when the pressure is changing quickly. All right, so the next couple, just to show you, they work the same way, so no need for me to say a whole bunch of numbers over and over again. There we go. So check yourself. Hopefully you got it. Again, you're not going to have to find the pressure 3 hours ago every single time. I just want to make sure you have that skill if you need it. The second sheet had us with the actual station model, 5C-2. So there was a station model that we had on the top of the page. Yep, that's the one. And you're going to use your reference tables, at least until you get really familiar with this. You'll need your reference tables to remind you what is on the station model. Now realize again, our pressure is in converted form, no decimals on there. Our pressure trend, we're going to have to put a decimal in when we read that, no decimal on there. The only time there's a decimal on these is under right there in the lower right corner, precipitation. They do use a decimal on that one. The temperatures are in Fahrenheit. This is one time where you do not label them because when these are little bitty things on a piece of paper, extra information is not necessary. We just know it's in Fahrenheit. So the first question is, what is the temperature at the station? Well, the temperature is 67. Get back off there. Second question, the wind direction and the wind speed. Well, the wind direction, this indicates the direction. Unless otherwise stated, we always assume that north is the top of the page. So this is coming from the northwest, so it's a northwest wind, has a whole flag and a half a one, and a whole one is worth 10, half a one is worth 5. Now they're technically knots, but it seems like they're often used interchangeably, knots and miles per hour. They're essentially the same. This is 15 knots. In miles per hour, it might be like 16.2 or something. It's not going to be a huge difference. All right, next question. What is the precipitation, the present weather? Present weather happens in the middle of the left-hand side. So we have this goofy looking thing here. So you'd use your reference tables. What does that goofy looking symbol represent? Well, it kind of looks like a T with lightning coming out of it. It's a thunderstorm. Next, the atmospheric pressure. Okay, that already popped up once. Upper right-hand corner, our 893 here is our encoded pressure. We need to decode it. So it turns into 989.3 when we add the 9 and add the decimal. The cloud cover, how much cloud cover is there? The central circle this all goes around is your sky cover. If it's open, that means clear skies. If, like this one, it's completely colored in, that means it's completely, it's 100% cloud cover. Overcast is another term for that. All right, and how has the air pressure changed over the past 3 hours? Pressure trend is right here in the middle of the right-hand side. It's gone down, hence the minus. How much has it gone down? It's gone down 1.4 millibars. You have to put the decimal in there. And it's been a steady decrease. The line on the right is not always there from my experience, but if it is, like this nice smooth line going down, it's a steady decrease. Sometimes they'll go down and then flatten out because maybe it decreased for the first hour, but the second 2 hours of the time period, it didn't. So they're trying to tell you that. But that one's not always on every single station model. Now, it didn't ask you what the pressure was 3 hours ago, but I'm kind of in that thing. So 989.3 is current pressure. It's gone down 1.4. So if I added it back on, that means 3 hours ago it was 990.7. Again, you didn't have to do that, but you know, I'm a dork. I like math. All right, next. So for the second part of the sheet, you had to draw the station model yourself. Now, station models do not require artistic ability. You draw yourself a little circle in there, and then you put all the information around it as best you can. Typically on the test, I'll even give you the circle so you don't have to be an artist. All right, so for this one, here's what you should have come up with. The sky cover is partial, so I went with 50%, though honestly it didn't say a percentage, so if you did 25%, I wouldn't yell at you. So I went with 50. Temperature is 48 Fahrenheit, dew point is 34 Fahrenheit. The wind is from the west, coming out of the left-hand side at 15 knots, whole flag and half a flag. When we encode the pressure, we have to drop the 9 from the beginning and the decimal point, so we keep a 9, a 7, and a 6. Always 3 digits there, no decimal present. The pressure trend, it's gone up in the past 3 hours. How much has it gone up? 1.6 millibars, and it's been a pretty steady increase. Precipitation is not listed, so there's none listed on the chart. That's okay. Not every blank has to be filled in. It's like it doesn't say thunderstorms or snow or sleet over here either, or the visibility, because they're not applicable in this case. And the second one, same deal. You have information. The temperature is 24 Fahrenheit. The dew point is 21. The present weather is snow. The wind is from the southwest at 25 knots. The pressure is 984.2 when we convert it. We put the 842. The pressure trend, it's steady, meaning it hasn't gone up, it hasn't gone down, so we just draw a line across. And the precipitation in the past 6 hours is 0.35. This is the only place you should have a decimal point, right there. All right, so I don't think they're too bad. Tonight's work is going to be some more station model practice, and nothing new, just practicing this because it's a pretty important skill in being able to read these. Thanks for watching, stay safe, and have a good day.